In this problem, we are going to write the formula for the function, and this is going to be a sinusoidal function, it says here, with a minimum at 0, -10. So I'm going to plot that real quick here, 0, -10, and I'm going to just note that that's a minimum, meaning the wave function does not get any lower than that. And then a maximum, so that was a minimum, now we go to a maximum at 2, -4. Okay, so that would be right here, 2, -4. Okay, so it's important to realize just the patterns of what's going on with sine and cosine functions. Technically, we don't know whether this is going to be a sine model or a cosine model, since they're both considered sinusoidal functions. So let's just quickly recap the difference between the two. If we're looking at a sine models pass through the midline right on the y-axis. Okay, that anchor point right there. It's heading upwards through the so-called midline. The other thing we got to look at is cosine. What's the deal there? So cosines pass through their maximum right at the y-axis. So that's the main difference. Now this isn't doing either of those. It is passing through a minimum. So we can actually achieve this by looking at the negative. So I should have labeled these. This was the sine function. I guess I labeled that one. And this is the cosine function. But if you look at the negatives of these, so y equals negative sine, that would just be a vertical reflection, and you'd have this pattern passing down through the midline. But with cosine, if you look at negative cosine, being a vertical reflection of the original cosine, a vertical reflection would have it going through the minimum on the y-axis and reversing that pattern as a vertical reflection. So the midline points wouldn't change, but their behavior at the minimums and maximums would be opposite. So this is really behaving like a cosine function, and in particular a negative cosine function. Okay. The other thing we can do here is determine midline and amplitude. If we go from the max at -4 height down to minimum at -10, that is a total height of 6, right? So halfway down from that, halfway down would be 3. You could think of it as halfway up as well. And I'm going to color that green. That is a height of -7. And that is my so-called midline. All right. So on this function, I've already got the midline now. It's -7. And I can actually surmise the amplitude, this distance of 3 that we highlighted from the minimum or the maximum to the midline. In either case is 3, so that's our amplitude. Don't forget we are going to have a negative sitting out in front of that. We're going to be going with a cosine here because of the location of the anchor point being right at a minimum on the y-axis. Okay, now let's talk more about the pattern. Notice with sine and cosine, when you go from a minimum to a maximum, or a maximum to a minimum, you've passed through half of the period. Okay, so we can't get to from a minimum to a maximum without passing through the midline. And then from the maximum back down to the minimum, we pass through the midline again and ultimately get to a minimum 1 period later. And I'm going to highlight that here as 1 period, and we can count that off since it took 1, 2, 3, 4 units to get through a whole cycle. The sinusoidal curve is easy to track in that regard. So the period equals exactly 4. All right, so that means we can calculate the b value. Remember, b is equal to 2 pi divided by 1 period. All right, so I'm going to calculate b over here. I've got a little room. And 2 pi divided by the period being 4, that'll reduce to just pi halves. So this is the b value I need to put in the function. So I'm going to write this function now as a cosine. All right. And we had a negative out front to achieve that minimum behavior first. We have an amplitude of 3. We have a b value of pi over 2. And also a -7 for our vertical shift, also known as our midline. All right, I hope that helped.